in history where the modern system took over from stuff in pursuit of the pharmaceutical industry's, what was it, petroleum chemical based stuff, and it totally abandoned a whole bunch of important, good, useful things.
Doesn't mean we can't do it again.
No, of course, yeah.
And that's really my point, is that it's time for us to stand up and say, enough of this rubbish. I mean, it's a contrast, what we've gone through. And for any big change, there has to be a big contrast. You have to be able to go, we had it all right, and then, oh, shit, now we're in the shit, and can we get ourselves back there? And what is the driving force behind this whole process? And, just get over it. You can get a hold of the tissue salts at the health shops and things like that.
So for people who are still not sure, this is homeopathic tissue salts, because you wouldn't take these salts as non-homeopathic versions.
No,
they could be toxic there.
Yeah, they struggle.
Potentially.
Yeah. Excesses of it. Yeah.
Okay. So then I was going to ask, how do you see that transferring to farming practices, the tissue salts approach?
Well, I guess the thing is that I saw in the whole process is that the singular cell is the same as an Angus cow.
Right.
And Paula says to me, Ewan's not an Angus cow farmer. He's not even a grass farmer. He's a cyanobacteria farmer. Now, and these are the things you go, it's perhaps quite right, but I quite like eating Angus beef and all that.
Yeah.
But the thing is that what we found out, that in a smaller scale in the cyanobacteria, you could see the reflection of the health of the soil. And what we did was their abundance as the single cell. So and this is in the ocean too, and they have the salts in the ocean. This is why they proliferate there. And so when the seawater close to the poles are exposed to high amounts of electromagnetic energy, the cyanobacteria explode in the springtime, and the whole food chain just goes kaboof.
Wow. And
that's what we need to do on the farm. You create an explosion over the winter period of time where these guys like moist conditions, they go absolutely bonkers. They proliferating like hell, and then, hey, presto, as it starts to dry out in the summer, some of the carbon oxidizes. All of these salts that were created in the single cell all become now available for the grass to grow and then for the animals to eat. And they say, we're just like the ocean. Yes,
interesting.
We are.
Okay, superb answer to that approach to how to bring it into farming practices. Thanks. Okay, so let's talk about electricity and nutrient availability. How do electrically available salts differ from water-soluble nutrients in agriculture?
First of all, you've got to have water.
Okay. Right.
And so if we base our system on a water-soluble, well, why don't we just make it hydroponic?
Okay, good point.
It's
that's not hugely popular. So
not hugely popular, and the products and quality of that don't go that well. Although I have seen some exceptionally good stuff, old stuff where they've used seawater.
Yeah, right. Well, there's always good examples of things that have gone well.
Yeah, and that was quite remarkable. Especially the work that Maynard Murray did. He was using seawater as a hydroponic base and growing tomatoes and all sorts of stuff, and they had a hell of a good result. Yeah,
right.
So, but water soluble is like, well, whatever's floating around goes up the plant. It's not. It hasn't got an order of events or anything. Right.
So that's not necessarily the approach you need to take. Whatever's floating around goes up the plant. You've got to have.
You got to have the right,
another
the plant. Well, see, look, all these plants and everything have a signaling system. And when people don't believe, they think we're really technically advanced because we've got the internet and we've got these cameras and we've got all this other stuff.
Yeah.
And it's like, have you ever had a really close look at the soil? If the mycorrhizae are going and all that, the filaments and everything. I mean, this is the internet of the, and we kill it.
Of the ground.
Yes, and we kill it.
Yeah.
But the information that being transferred and the nutrient flows and the macros and the micros and, like going around the place is just phenomenal. And don't believe.
That reminds me of the mycelium network.
Yes.
Yeah.
Yeah.
Stamets, right?
That's right.
Yeah.
So there's an intelligence beyond what we can comprehend, because what we saw when we look at those minerals in the genetic sequence, then there's an intelligence in that about the coding and the information and how things work. And then there's also an intelligence in these salts and the cellular structure and how they function as well. So a plant that's growing, a particular plant, say like a grassland, tall grass plant, needs lots of silica. So one, it's going to grow in a place where there's enough available silica, to sustain it.
Yeah.
Two, it's going to send us messages down, send me this, send me this, send me this. And then we go into growth changes. Seeds. Oh, we're going to seed. We need carbon. I need lots of carbon in that seed for the seed to become...
In that season.
Yeah, in that season. So we go, we're into dry part. Oh, it's hot and it's dry. Oh, the carbon oxidized from the ground, came up to that, and they took it in and went into the seed.
Hang on, is this just the perfect reason why hydroponics doesn't work?
Well, it's one of many of the reasons that the whole farming...
The dry thing seemed suddenly very important, which
Well,
hadn't
it's
really
one
occurred
of
to me.
these seasons. I mean, we're in January when we're recording this now. We're going into and we're seeding a seed.
True.
Seeding,
Yeah.
And so these are the things that happen in nature that are discounted because, it's all bullshit. Hold on here. If you go and measure a seed, you look at your mineral content and all that sort of thing as far as the quality, but it's got to have carbon as an energy source for when it explodes into growth.
Okay.
Without it, it's shot.
Okay.
So the mechanisms of nature fulfill the whole process. If you give the soil what it wants and the plant corresponds to the soil that knows that it can get those sorts of minerals and that sort of process, it will do what it's required.
Right.
Now, all of this goes into different climates and what you're growing. So, like if you go to Central Otago, you can grow cherries. Got clients down there growing big, fat cherries, You couldn't do that here. Even if you got the soil exactly the same as them down here, because of the climate...
Because we don't have the same dry period?
That's it. We don't have the same dry in the whole process to fit that plant's requirement.
Okay.
So what happens is that certain parts of the country, which New Zealand has quite a few extensive different parts, and yet we've only got one model.
Yeah, that's funny for a little country with so many different parts to only have one model.
Yeah, it's crazy because Well,
it's also crazy that we're little but have so many different terrains.
Yeah, but it's a beautiful example of the whole planet.
True.
You go to the West Coast in the springtime and get 2 meters of rain in just over a month, and you go, oh dear.
Wow.
Yeah. And you go to Central Otago and you might get, 300 mils of rain for a year, which happened one afternoon on the West Coast, which is only 40 miles in a straight line. And then you go to Southland and it's bloody freezing and it's raining and all the time, and they're doing high production they do in the Waikato, 400 miles north, in a lovelier, nicer, warmer climate.
Keen to dive deeper? Check out our audiobook and EcoFarmer's Discovery on Spotify, or grab our free ebook, The 6 Things You Need to Improve Soil and Farm Profit. Links in the description.